Welcome to Solving Systems of Inequalities by Graphing. The emphasis here is inequalities. You know how to graph and you know how to solve systems. If there's an equal sign, you just find a point where they meet. But when it's an inequality, there's a wide range of answers. So let's go over first about doing a normal, just single one of these. Right, so it'll be a sort of a review of simply just graphing a linear inequality. So we will change this one. I'm going to make it y-intercept form, y equals mx plus b. So that means first I'll remove the 6x and bring it to the other side because I want the y by itself. So I'm going to subtract 6x from both sides. Gives me negative 2y greater than or equal to negative 6x plus 12. Now I'm going to divide by the negative 2, the coefficient of the y, so I can get the y by itself. Notice I am reversing the inequality sign. Really vital thing here. Okay, the negatives cancel and we get a 3x. Negative and positive makes this negative. 12 over 2 is 6. So let's count that before we do the other one. I think I like that arrow to be a little bit more like just an arrow, and thus a reminder that we have to switch it. All right, really vital. If you divide by a negative or multiply by a negative in an inequality, you have to reverse the inequality sign. That's one of those, don't forget to do that. Really vitally important. Next thing, power to the computer, which I have done. Next thing, we're going to graph that. We're going to graph it as if it was simply a y equals 3x minus 6. But because of this, we can have a solid line. So we'll do a solid line. So we're going to temporarily graph it as an equal. And then we're going to have to figure out which side to shade for this. So let's go to where it's negative 6 for the y-intercept. 3, 4, 5, 6. And then we have a slope of 3 over 1. 3 over 1 is the slope. So it's up 3 and over 1, 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 up 3 and over 1. I can go the other way and go down 3 and over the other way, but I don't have that much room, so I don't need to do it that much. Now, this would be a dashed line if there was not the little half equal underneath it. It's not, so we'll do that. What we now need to do is to test a point. Because we need to know, are the answers to it over here or are the answers over here? Because there are multiple answers to this. Either everything over here counts as an answer, and every point there you could plug into both of them and it would be true, or all those would be false and it would be everything over here. Don't know which way, so let's find out here. The way we're going to do is we're going to pick a point on one side or the other, and 0, 0 is the easiest way to do it. So I'm going to test 0, 0, and I'm going to go back to the original for testing. I think I'm going to write that clearly. And I'm going to plug in 0 for the x, minus 2 times 0 for the y, and see, is it true that it's greater than or equal to 12? So when that happens, 0 minus 0, that's 0 greater than or equal to 12. I'm afraid 0 is not greater than 12, or it's not equal to. That means the side where 0, 0 is does not get shaded, only the other side does. I don't think I want to do it in red, actually. I'm going to do it in black. I'm only going to do a little bit of lines to show it's over there, because we don't know yet where the second one is. But we're now going to do the second one. I am going to put that one. I guess I'll do the same thing. I could do an XY table, but I don't think I want to. I think what I want to do is to make it a y-intercept form again, for y is greater than, and negative 3x plus 12. So I'm going to divide by the 4, and y is greater than negative 3 over 4x, and 4 goes into 12 3 times. Now, in this case, first we'll go to the y-intercept, and I'll go to positive 3. And I'm going to think of this as equal for a moment, but not really. I'm just going to think of it in my head so I can graph it, and I have a slope. Oh, let's rewrite that. Y didn't get included. Negative, and let's make that a better 4. So negative 3 over 4. That means I'll go down 3 and over 4, down 3 again and over 4. But I could do it where it's 3 over negative 4. So I can go up 3. Just wait a second. I think I did something wrong on these. I went the wrong way in it. When I went this way and this way, I was doing negative and negative. So I need to remember that one was supposed to be negative and positive, negative 3, positive 4. And then if I do it the other way, 3 over negative 4, it's up 3 positive, and then negative 4 the other direction, away from or into towards the negatives of the graph. Now, here, I can't do a solid line. I have to do a graph, a dashed line. And the reason for that is twofold. There's the practical part of when you see the inequality without an equal sign under, you know it's dashed. The reason for that is because the points on that line will not satisfy these two equations. If I picked a point right on it, like this one right here, and plugged it in, I would get one of them being false, if not both of them being false. Actually, at least one would be false, because it would not be equal to the 12. Now that I've done this, I have to test a side, and again, let's test 0, 0. If 0, 0 is available, if the line actually went through 0, 0, then I wouldn't be able to use it, because we wouldn't know if one side or the other was needing to be shaded. So that's this one here. So I'm going to do 3 times 0 plus 4 times 0 is it greater than 12. So I get 0 greater than 12, and this is not true. Because 0 greater than 12 is not true, that means the top part of this, I'm going to do it blue, top part of this needs to be shaded. Now we can see where both of them are shaded at one time. And that's the area, or that's the place where the answers are. All of these points, disappearing on me. Let's see how close I can get better at it. Okay, a little bit better now. Oh, it went away. This might be as best as I can do because it's not cooperating really well. Okay, so this is the area where all the possible answers are. So for instance, 10 and 10 here, if I put 10 and 10 into both of those, I would get two statements. Or if I took a point like the one that's here, which would be negative, let's say 1, 2, 3, 4, 4. Well, it's not negative, it would be 4 and 2. and I plugged that into both of those, the X and the Y, it would also, they would both be exactly right. If I did 8 and 5, which would be about here, 8 and 5, and plugged them both in, those would make it a true statement as well. Even the ones down here, where it might be like this, 9 and -1, all of those points and every other point in there will make it a true statement. So the shaded area, and that's what you need to do, is you need to show shaded areas. I'll just go over those because I don't want you to think that you should give me points. You just have to show this physically. And that's how you solve by graphing, is showing the area there, the shaded areas. Okay, now there is another one that we're going to do. That's one. Let's do this one. Now on this one, I'm going to, for this one, change it to y-intercept form. No, slope-intercept form. Yeah, getting it wrong because that's the y-intercept and the slope. So I have negative y less than or equal to negative 2x plus 3. I'm going to have to, with this negative, I can either multiply by a -1 or divide by a -1. But then I have to remember now to switch that. So I'm going to get y greater than 2x minus 3. I'll graph that. -3. Oops, I went to +3. Let's go to -3. And I have a slope of 2, which means 2 over 1, up 2 and over 1, up 2 and over 1, up 2 and over 1. And I can make it pretend they're both negatives because the negatives would cancel, but it allows me to go down 2 and over 1 the other way. Okay, so I'm going to draw the line, but this is where I have to make sure that I do it as a dashed line. Now, let's say on this kind of a thing where I accidentally draw it as a solid line. If I'm doing it in pencil, I would just erase. But if I'm doing it in pen, well, my choices now are to make like a big dashes going through it, and then say about it, actually say dashed. Okay, because if I don't say that, the lines might not be enough for someone who's grading it to be certain that it was really dashed. Okay, now let's figure out where the point, which side to shade. Let's put 0, 0 into the original. So I get, using 0, 0, 2 times 0 minus 0, is it less than or equal to 3? 0 less than or equal to 3. Yes, it is. So that means now we shade the side where the 0 is, and very little because we have to get the second one now in order to find where they meet, and that will fill in. So the second one, for graphing it, this one lends itself easily to an XY table. Okay, so for this, I'm going to pretend it's equal in order to get the right point. So if I make the X, let's pick some numbers on both sides as 0. Let's say I do -5. So I do -5 plus y is less than 2. Actually, my whole point was to make that equal. So let's do that now. So I'm going to say it's equals 2, just to find the places where the line should be, but then we'll use a dashed line. So now I'll add 5 to both sides. And so y is equal to 7. Now let's do 0. If I put 0 in for here, that just gives me that y is equal to 2. Now let's do a +5. Okay, so that's going to be 5 plus y equals 2. And subtract 5, and y is equal to -3. So now that I have those points, let's graph them. The other one in black should have been in blue. I'll do this one in green. -5, 1, 2, 3, 4, 5, and 7. 1, 2, 3, 4, 5, 6, 7. So I have a point right there. And then the second one, that's that one. The second one is 0 and 2. And the third one is 5 and -3. Ooh, it does look like all three of those dots can make a line. And this is where I need to remember that they're dashed lines. Now, here is where I need to figure out where to shade. And again, the 0, 0 works well. But let's pick let's pick something else. Let's pick a number like here. If I pick this one, that's on one side or the other. And this one is 0 for the x and 10 for the y. So let's put that in and see what happens. I'm going to test it here, running out of space there, where I'm going to put 0 in for the x plus 10 for the y less than 2. Oh, that says, is it true? Is 10 less than 2? No, it's not. 10 is greater than 2. If it is, if this is no good, that means this is the area to shade. Because it's where both of them are true at the same time. Okay, I'll make sure I get that whole area without being too obsessive about it. Well, it goes up to here too. So this whole area here, and going beyond it as well, we just don't show it on the graph, but it would go on forever in those directions. Every single point there would make these two inequalities correct. And that would be the answer, showing that. It doesn't have to be in red for yourself, by the way, just showing that it's clearly including all that area. Okay, now let's take a look at the last one here on this page. One of them's already set up. We'll use the 1, positive 1, and y-intercept or slope of -3. We'll go down 3 and over 4. 1, 2, 3, 4 this time, going the right direction. Down 3 and over 4. And then I'll do it the other way where negative on the bottom of 4. So it'll be +3 and then -4. +3 and -4. Okay. And it looks like it's a solid line because of the equal sign or the half equal sign under it. I'm going to make a solid line. And then I'm going to test 0, 0. So I'll use the 0, 0 here. And that means 0 greater than or equal to -3 over 4 times 0 plus 1. So 0 is greater than or equal to 1, because of course that becomes 0. That is not true. Since that's not true, we're going to shade the other side of it. Black, we're going to shade it here. Now let's graph this one. I'm going to subtract 3x. 4y is less than -3x minus 8. Divide by the 4. Y is less than -3 over 4x minus 2. Let's do 3. So let's go to -2 and then down 3. So I'll make the slope first -3 over 4. That means down 3 and over 4, down 3 and over 4. And then I can do that. So it's 3 over -4. 3 positive and 4 negative, 3 positive and 4 negative. Okay. And this one is a dashed line. So let's do the equation. Back to there. Okay. Oh, look at that. Parallel lines. So let's see where the shading is. If the shading is this way, then they still have this area that counts. If the shading is this way, that means there's no possible solution because there's no place where both of them connect to um, to be solving for a point, so or an area. So let's figure out. We can use 0, 0 again. So we'll test 0, 0, and we'll test it on that one. So 3 times 0, 0 plus 4 times 0, 0 less than equal to less than negative 8. So 0 less than negative 8. That is not true. 0 is larger than negative 8, just like negative 4 or negative 5 is larger than negative 8. So that means that the side here is not so we have to shade over here. And that means that there is no place where they actually connect. There's no solution to it. And that's what we say. So the actual answer to this is to say no solution. And the work figuring out the graph is how we know that there was a good faith, serious effort made. Let's do that. Good, no solution. So we have here a couple of them where there are solutions by having these shaded areas, or there's no solution when it's parallel lines.